In product design and manufacture, factors outside of functionality must be considered. How a product is assembled also has an impact on overall productivity for the manufacturer. Our partner Alberts recently used our new assembly inspection tool to create a use case study of tool usage on their product, a crusher assembly which is part of a smoothing machine. Albert's use case evaluated the tool in two positions and the effective range of the tool being used at the particular step. This allows for optimized detailed assembly notes and instructions to be created, and potentially highlight an area where redesign is required to suit assembly efficiency. With BricsCAD Mechanical V24, manufacturers like Alberts can optimize the design so that an assembly technician can effectively and efficiently assemble a product. Let's take a walk through and look at the assembly inspection tool. To start the assembly validation process in BricsCAD, we first need an as-built sequence. An as-built sequence mirrors the order in which the components are assembled in the real world. This sequence can also be used in creating assembly instruction documentation. The assembly inspect command initiates the inspection tool process. Select the newly created as-built sequence in the assembly inspection dialog and verify the steps in the sequence match the build order. In the Configuration tab, select the 3D model of the tool required in the assembly process, and map this to the components it's used on. This use of 3D tooling models allows flexibility and customization for tools which may be specific to the product or manufacturer. The next step in the process allows rules and parameters being checked on the assembly to be configured. There are 3 parameters which can be selected to be configured. These are tool usage. This rule evaluates whether tools have sufficient maneuverability space. Like in the configuration dialog, the profile setting dialog also allows the tools to be mapped to components here. There is an acceptance range which is completely customizable to the user's needs and requirements. Global translation. This rule evaluates the global translatability for the component in the current step. And visibility. This rule evaluates the visibility of components from the assembly person's position. We are going to focus on tool usage like in the Alberts use case. With all parameters configured and tools mapped, the evaluation process can now be run. The results now show the evaluation of each of the rules for each step. In terms of tool usage, where no fasteners were found in a step, an error message will be displayed. Let's look at the results of the fasteners on the connector and compare these to the use case from Alberts. The Assembly Inspect feature gives us a visual representation of the tool with the results. As we can see in the tool's current orientation, we get 2 results with good maneuverability of 185 degrees, and 2 results which don't have as good maneuverability at only 85 degrees. These results match that of the Alberts case study, and Alberts have shown that by reorientating the tool, it is possible to get a complete unrestricted maneuverability. This change in orientation can be documented in assembly manuals and ensure that the product has been assembled in the most efficient manner possible. The use case also states in the remarks that the grill fasteners are unrestricted. Let's have a look at this in the BricsCAD results. We can see a 99% maneuverability on the results step, and when we look at the visual, we can see that indeed, the fasteners on the grill are completely unrestricted in their movement. This is an ideal condition for assembly technicians. The report also states that the shaft holder is restricted, but okay. Let's get a visual representation of what this restriction looks like back in BricsCAD. We can see the tool is restricted due to the angle of the shaft holder from the face of the main assembly. This gives Alberts the root cause as to why it is not unrestricted, and a good heading for a design revision should they choose to improve the tool maneuverability. In this session, we've overviewed the steps in the assembly inspection tool, and looked at the type of use case report you can create and what you can do with this data to enhance the efficiency in assembling your designs. Discover the BricsCAD difference by validating and optimizing your design's producibility prior to manufacture, and avoid costly mistakes.